Hi, and welcome to Calculus Examples. I'm Dr. Finch. Today we're going to look at partial fractions in integration. So we have an integral here where we have 5x plus 16 over 4x minus 4 times 2x plus 1. And they were nice enough to take our denominator and split it apart for us. So that is going to be one step we don't have to do in this problem. You'll notice that the denominator has a degree of 2, meaning if we multiply this out, we'd get an x squared in our polynomial. The degree of the numerator is 1 because we only have one x. So that tells us we don't have to do any polynomial division before we set anything up. We can just get into the problem. The other thing that you'll notice is that we have distinct linear factors in our denominator. So that also is going to make our lives a little bit easier. When we split this up, we are going to have a over x minus 4 plus b over 2x plus 1. So this is the setup for partial fractions. You want to take every part of your denominator, all these linear terms, put each of them by themselves, an addition sign in between, and use capital letters just so that things don't get too mucked up to determine the numerators. Now, those are unknowns at the moment, but we are going to figure out what they are. We're going to do that by multiplying the entire denominator all the way across by x minus 4 times 2x plus 1. So on the left-hand side, when we multiply both terms by, or the fraction by that, we get our numerator back. On the right-hand side, our x minus 4's cancel out, and we have a times 2x plus 1. And then we also have b times x minus 4. We're going to rewrite this a couple times. So let's first start off with a 2ax plus a. We're going to distribute that a throughout. We are also going to distribute our b throughout, plus bx minus 4b. You'll notice that kind of the way to think about this is you're going to put your number first, then your capital letter, and then any x values afterwards. One last time, we're going to rewrite this. And what we're going to do is we're going to take the terms with an x in them and we're going to smush them together. So we get 2a plus b times x plus, now our constant terms will be a minus 4b. When we have this set up like we have right now, we know that the coefficients have to match up in our polynomials. So the number in front of the x has to be the same on both sides. So that tells us that 5 is equal to 2a plus b. It also tells us that 16 is equal to a minus 4b. Now we have a system of equations. We have two equations and two unknowns, a's and b's, and we can solve this. So we're going to do that right now. And if you find explanations like this helpful, please subscribe. This channel does Calc 1 and Calc 2. All right, so we're going to move on to, let's just write this as b is equal to, and you can use any technique you want to solve your system of equations. If you have a favorite, go for it. I love seeing people being creative with this stuff, right? You could multiply your second equation by -2 all the way throughout and then add both equations. That could be fun. I'm just going to do a simple substitution, and then we are going to distribute this 4. Don't forget we are also distributing that negative sign. Oh, go. I made a typo here. That B should be an A, and I do apologize. There we go. All right, so let's write this up again. We have 16 is equal to 9a minus 20. So that gives us 36 is equal to 9a, or a is equal to 4. So that is our a value there. let's pop that back in. I'm going to go over here. We have b is equal to 5 minus 2a. So we are going to take 5 minus 2 times 4, which is 5 minus 8. So that's going to give us b is equal to a negative 3. All right, now that we have our a and b set up, we can put that into our integral. And I'm actually going to put this on the next page. So we started off with 5x plus 16 over x minus 4 2x plus 1 dx. And this is splitting up into two integrals. Our first one is 4 over x minus 4, and our second integral is negative 3. Well, I'm saying them as separate, but they're really, you can smush them together. It's an addition, so as you wish, right? I am going to split them up just so that we kind of remind ourselves how to do this, and you might feel comfortable with this already. If you do, just go straight ahead for this. Not a problem. And just fast forward to the end to make sure you're on the right track. So our first integral, 4 over x minus 4, this is going to integrate to 4 natural log of everything in the bottom, our linear terms. And then, of course, we have a plus c. The second bit here is going to be a little bit different because of that 2 in front of the x on the denominator. And I just wanted to show this to you. Once you get used to this, you don't have to actually go through and do this work. It'll just come naturally and you'll automatically do it. In this case, we'd have a u is equal to 2x plus 1. Our du is 2 dx. And that tells us that 1/2 du is equal to dx. So this gives us the integral of negative 3, and then we'd have 1 over u times a 1/2 du, which would end up being a negative 3 over 2. And the antiderivative of 1 over u is just natural log of u, which would give us negative 3/2 natural log of 2x plus 1 plus c. So you'll notice what's going on here in general is when you have a number out in front of your x on a linear term like this, you are going to divide out by that when you have your natural log and you do all that mess up there. So that's just one extra step. You don't need to do a u substitution if you remember how it works. Depending on your teacher, I would ask just in case. And then our final answer for everything is going to look like this. Now, I do want to caution you that a lot of times in Calc 2, things get a lot more difficult because the answer in the textbook is not always the answer that you'll see on your paper because they run it through computer programs or they do some funky stuff with like natural logs. So for instance, this one, if you wanted to, you could write it as natural log of x minus 4 to the 4th times 2x plus 1 to the negative 3/2 plus c. And that's just a lot of extra work. You're already doing a lot just for Calc 2, so I would advise against trying to make it look exactly like the back of the book. Just do what needs to get done, work on your algebra, and you'll get there in the end. Thank you for listening.